Hi everyone. In this video, I'll talk about evosuite, an automatic test case generator in Java. I'll talk about its license and distribution, give a brief description about the tool, its features, and finally conclude it with a demo. evosuite is licensed under the GNU Lesser General Public License. It's an open source tool. Binaries are downloadable from the link specified here. evosuite generates test cases automatically for Java classes. It targets the branch coverage. It uses a search-based approach to create test suites. Algorithm that is used here is genetic algorithm that we are going to discuss in the next slides. For generating the test suites, evosuite adds small and effective sets of assertions which helps developer to detect deviations from the expected behavior. It can be used in multiple ways. It can either be used on command line by using an executable jar file, or it can be used as a plugin integrated with IntelliJ, Eclipse, and Maven. Why do we need to use evosuite? Software testing is an important task of software development lifecycle. It is an error-prone task, so automation is needed. To find bugs, there should be proper set of test cases and oracles that assess correctness of behavior observed by running these test cases. So what are these oracles? Oracles can verify if the outputs of the test cases are the expected ones or not. evosuite is a tool which generates test cases along with the assertions for Java code. It supports various coverage criterion, but the default one is the branch coverage. Let's now look how does this evosuite works. evosuite basically needs Java bytecode for the class which is being tested as an input. It uses a search-based approach which includes whole test suite optimization to create test suites. When the 100% coverage is reached, it adds assertions to the created test cases. These assertions are generated using mutation testing. We will further discuss about whole test suite optimization and mutation testing. Let's now understand what is the whole test suite optimization. In white box testing, test suites are generated by considering each coverage goal for a given coverage criterion, assuming all coverage goals are equally important. But in fact, many coverage goals are infeasible. That is, there exists no test case that would cover these goals. Furthermore, some test cases targeting a coverage goal can actually satisfy other goals accidentally. In whole test suite optimization, test suites are generated by targeting an entire coverage criterion rather than targeting an individual coverage goals, thus producing optimized test cases. Few terms that we need to consider during this whole test suite optimization are search space. Search space is a set of all possible tests for a given problem. For example, consider a divide function that is taking two input parameters, and the search space for this divide function would be all possible combinations of pairs of integers. The next one is search operators. For a test case, make some modifications like adding or removing the statement, increasing or decreasing an integer values, or modifying a character in a string. So these are called as a search operations. And then we have fitness function. It can be considered as an evaluation function of how good a test case is. Then we have the genetic algorithm which is used by evosuite for creating the test suites. In brief, this keeps a population of solutions. Solutions here means test cases sets. This first initializes a random test case and then applies mutations randomly, like by incrementing or decrementing an integer, adding or removing a statement, and then calculates the fitness function for each solution. Apply back the mutations based on the fitness values. If the solution is optimized, then the solution is kept, or else it is thrown off. Mutation based assertion generation. Mutation testing is like introducing artificial defects or mutants into the project. Test cases are then evaluated with respect to these mutants. If a mutant is not detected, it shows that test suite is deficient and a new test case had to be added. After the test case generation, evosuite runs these test cases against unmodified program as well as against mutants to come down to reduced assertions. Coming to the features of evosuite, by using this tool, we can get optimal number of tests, that is, only the ones that contribute to coverage criterion. Assertions are created by evosuite, which helps to capture current behavior of classes that are being tested. Let's now go through a simple demo of evosuite generating test cases for the Java code. Right. Starting with the demo, evosuite can be used either on the command line using executable jar or using plugins for Maven, IntelliJ, and Eclipse. In this demo, I'm going to use command line. For evosuite to run, we need to have Java installed on our machine and Apache Maven too. Apache Maven here is being used to compile our project. Recommended version of Apache Maven is 3.1 or latest. The project that I am going to generate test cases for using evosuite is tutorial stack. As you can see, there are 3 files over here. The pom.xml, which is the Maven build file, and then we have the source code in which we have test and main folder. The main folder is the actual source code for which we are going to create test using evosuite, and the test is a test suite folder. Let's now compile the project using Maven. Let me first go to the source code folder and compile the project using Maven. Maven compile. So as you can see, the build is success here. Now we can go and see the bytecode of the stack class that we have run under the target folder. So the target folder is created and we have the stack.class file bytecode over here. Right. Now let's use evosuite for testing, for creating the tests. For this, we had to download the executable jar file. So I'm downloading it using wget, and the one that I had to download is I had a copy of it since that I don't want to mess up the demo. Let me get through it. I'm getting a jar file. So this is getting downloaded, and then I'll also install this runtime jar. This is used for the evosuite created tests running purpose. Alright, that is getting downloaded. So now we have the jar file of evosuite. Let's run this jar using java jar command. Right. So once if it is run successfully, we would just see an evosuite 1.0.6 over here. So we have our evosuite up and running, and for the evosuite, in order to generate the test cases, it mainly requires 2 things. One is the class which is being tested, and the other is the class path. Class path is where it could find the bytecode of class that is being tested. So that is given through the command. The command looks like this. So we have the jar. Let's use the same, which is the executable, and we will specify the class using -class argument, and the class that we're gonna test is tutorial dot We got to give the full name of the class over here, including the package name, and specify the project path using, sorry, class path using project cp, and give it as the bytecode location of the class. Unknown class, be sure its qualifying name is correct on the class path is properly set with -project cp. Looks like I've given a wrong class name here. Tutorial.smallS was given. I've just rechecked it. So this should be generating our 2 new files into the folder. Let's wait on for that. So the command is still running. So once this is done, we must be able to compile and run the test cases that are being generated by evosuite. So it looks like the test case creations are being done. So as you can see over here, we have got 2 new folders here, evosuite tests. This is the test file that is being generated by evosuite automatically. You can see for the class there is an annotation over here, run with evorunner class. This means that the tests are being run with evorunner, not by JUnit. And there are few other parameters that are being mentioned here, evorunner parameters. And then we have scaffolding.java. So this is a file, something which is like a skeleton which can be used while creating the test cases. So the test class over here is getting inherited from the scaffolding class, except that each class here is being annotated with the evorunner, and we don't have such annotation in the skeleton classes. And there you can see a before class and after class which is being run for every test, in order to make sure that there are no, I mean, there might be few steps that need to be run for every test. So that could be in order, rather than duplicating the code, that is being just put in the before and after. Alright. And then we also have a evosuite report. So this is basically the reports that are being generated by evosuite. Now that we have the test cases, let's compile the test cases and run the test cases that are being generated by evosuite. So in order for compiling the test, the compiler needs few other things. Some of they are like evosuite runtime that we have already installed, and it needs JUnit and Hamcrest core. So for that, let's install those dependencies using Maven. And this is a command for downloading the dependencies that are given in our pom.xml file. Alright, you could see the Hamcrest core is being downloaded and the JUnit is downloaded. So we have these libraries in our machine, and let us actually give the compiler the path by give the compiler these files by setting up the class path. And I have this class path copied, since that I don't want to mess up things. Alright, I think there is no class path. Let me just write it. Just export. Class path. Let's give the location of the bytecode where it could find for the class that it got to test. And let me give the runtime jar evosuite. Dot jar. Let me give the JUnit and hamcrest code too. JUnits are found under target dependency. JUnit jar. And then let me give the hamcrest code dependency, which is again in the target dependency folder. Hamcrest -core. This is 1.3 version. 3.jar. I wish the path is correct. Target classes evosuite standalone runtime jar file, and then we have I think I missed something over here. The path for this is evosuite having test. Right. Let me run this. Bad assignment. Maybe the spaces. Yeah, so we got to create the environment variables without the spaces. I think I have set the path. Let me now compile the test and check if the class path that I have set is correct or not. For compiling the test, let's use javac. Compile the test folder. On the evosuite tutorial, and compile all the Java files. No matches found. Oh, I think I've given a wrong. This should be stack.java. Let's now check if this compilation is correct. If the compilation is correct, then we need to see the class files under the test. Alright, we could see the class files for the scaffolding and the test class. Let's now run the test. So in order to run the test, I got to use the JUnit. I have that command copied. Right, I'm running this. Alright, so we could see that 6 tests are there and all of them are passed. We could see there are 6 tests, 4, 5, 6, and all of them are passed. So that's it, we now generated and executed evosuite tests.